All right, let's take a look at solving by completing the square. So I've chosen for this case exercise 13.10. This is from the IGCSE textbook for year 11. So we've called how to solve by completing the square part 1. And part 1, I'm going to just take a basic quadratic. Notice the value of the coefficient of x squared is 1. So if there's no value there, it's either 1 or -1 if it's a minus. And I'm going to just show you how to solve that. So I'm going to do that actually in several parts. In fact, I might even do several parts. Let's have a look. We're going to have... No, I'll just do it in 2 parts. I think that'll cover everything. All right, nice and simple. There are several steps we need to take. The first step I'm going to take is I'm going to subtract the 19 from both sides. That's the C value. So let's have a look at doing it. So I'm going to restate the problem. So x squared minus 9x plus 19. And I always restate the problem so you can see what I do in my next step. So I'm going to subtract 19, and therefore I've got 19 now is on the other side. So I have x squared minus 9x. Nice big gap there. I'm going to leave that gap. I've got minus 19 over here. Now the next step is the important one. And the next step is to say we're going to add to both sides the b value. Now the b value is minus 9. Here it is. That's the b value. It's the coefficient of x, or coefficient of x to the 1. I'm going to add that to both sides. So here it is. But I'm also going to halve it on both sides. And I'm also going to square it on both sides. So what I've done is I've got rid of the 19 onto the other side. Step 2 was to take the b value, halve it, and square it. And then add it to the same on the other side. Take the b value and halve it and square it. So let's see how that plays out. Now, on the left side, this is very easy now. This whole thing here, that whole thing there, now becomes a very easy expression. It's going to be x to the squared, and the contents of that bracket there, which is minus 9 over 2, just goes there. And there's our completed square. Now, of course, we do have some stuff left over because it's a completed square and some other stuff. So the other stuff's over here. Let's resolve this. I've got a minus 19, and I'm going to add to that. Well, I've got a 9 squared. Well, negative 9 squared is going to be 81, and 2 squared is going to be 4. So I've now got minus 19, and I've got 81 over 4. Just reaching for my calculator. So I'm going to do this next one on the calculator so you can see it nice and easy. So I've got 81 over 4, and I'm going to subtract 19. Here it is. 81 over 4, and I'm going to subtract my 19. And I get, not very good focus. Here we go. That's, you see, that's good. 5 over 4. I get 5 fourths, 5 quarters, yeah, is equal to 5 over 4. And I'm going to keep it as a fraction. I could have 1.2 or something, but I'm going to keep it as a fraction. You'll see why in a moment. So I've got now x minus 9 on 2 all squared is equal to this thing here. Now the next thing I'm going to do is I'm going to find the square root of both sides. So I'll restate the problem. I'm going to just plan this out a little bit better. So I'll put the equals, keep the equals under each other. But I put the 5 over 4 over here now, and I'm going to find the square root of this side, and I'm going to find the square root of this side. And as I find the square root of both sides, well, this has to be now plus or minus 5 fourths. Of course, the square root and the square cancel each other out, because the square root of a square is just the number that's inside. So I've now got 9, x minus 9 over 2 is equal to, now we need to leave that gap there, so I'm going to have square root of 5, and it's the same as the square root of 5 over the square root of 4. So the square root of 5 is equal to square root of 5. Square root of 4 is actually a 2. And I'm going to add now at this point, it's going to be still plus or minus, and I'm going to add 9 over 2 to both sides. 9 over 2. And the only reason I'm doing that, of course, is to get rid of over here, because a positive 9 over 2 minus 9 over 2 is 0. So I'm left with x is equal to, now, I'm going to write 9 plus or minus root 5, but the denominators are the same. That's over to 9 over 2. This is a root 5 over 2, so the whole thing is over 2. So that means now I can just go ahead, very, very straightforward, and I'm now able to solve this whole thing. So I'm going to write either x is equal to, and I'm going to do two things here. First of all, I'm going to add 9 to root 5 divided by 2, and then I'm going to do it again. This time go 9 minus root 5 over 2. So first, I'm going to go 9 plus root 5 and divide by 2. Let's have a look. 9, here we go. So it's going to be 9 plus square root of 5. Oops, too many. Root 5, there it is. And I'm going to divide by 2. And I get 5.6. I'm going to do it to 2dp. I'm going to go 5.6 2, I'm going to call that. It's 5.62, and I put 2dp here. Now, I've also got a 9 minus all of that, so I'm going to do the same thing again. So I've got or x is equal to, and I'm going to write 9 minus root 5. Here it is, divided by 2, and I get 3.38. That works well. 3.38, and again to 2dp. And they are my two solutions. So that's the first step. So a nice straightforward thing to do. The idea here is to do a ton of these things. Do as many as you can. And remember, we're not completing the squared. We actually solve using the completed square to solve. If we were completing the square, I'd do it a little bit differently, but essentially it's the same kind of process. Anyway, that's the answer. I hope that makes sense. Let me know.